Hello, welcome. This is CAE May June 2010 Pure Mathematics paper 31. There are something around 10 questions, but the 10th question is from the chapter vectors and it is including the topic planes, which is deleted in the new syllabus. So therefore, we are not doing that paper or that question. So rather than we'll do 9 questions. So let us start with the first question. First question is an inequality. So what am I supposed to do it? I'm going to square on both sides. So x plus 3a whole square. Whenever we have inequality, so it is the best method is squaring on both sides. So when you square on both sides, it does becomes a quadratic equation. So I expand that x square plus 6ax plus 9a square is greater than 4 times x square minus 4ax plus 4a square. Then it becomes x square plus 6ax plus 9a square is greater than 4x square minus 16ax plus 16a square. Bring all the terms on one side. So 0 is greater than 4x square minus 16ax plus 16a square minus x square minus 6ax minus 9a square. It does becomes as 3x square minus 22ax and 16 minus 9a square. 16a square minus 9a square will become 7a square is less than 0. So what I have done it out, I have 4x square minus 6 square I have written as 3x square. 16ax minus 16ax minus 6ax has been written as minus 22ax. Now this is a quadratic. Factorize this quadratic. I'm directly writing the factors. It should be 3x minus a times x minus 7a should be less than 0. So when it is like that, so I got two roots, which is a upon 3 and 7a. So whenever it is less than 0, x lies between the smaller root on the left side and the bigger root on the right side. Because a is a positive constant, we take it as x lies between a upon 3 and 7a. That's going to be the answer for the first question. Now coming to the second question. Solve the equation sin theta is equal to 2 cos 2 theta plus 1. So what am I going to do it on? I am converting that cos 2 theta in the form of sin theta. Cos 2 theta formula is 1 minus 2 sin square theta plus 1. So I get sin theta is equal to 2 minus 4 sin square theta plus 1. So bring all the terms on one side. It becomes 4 sin square theta plus sin theta. 2 plus 1 is 3 minus 3 is equal to 0. So it's a quadratic. Use the formula minus b plus or minus square root of b square minus 4ac minus 1. Let me write over here minus b plus or minus square root of b square minus 4ac upon 2a. So minus b plus or minus square root of b square 1 square minus 4 times a is 4 and c is negative 3 upon 2a. 2 times 4. So sin theta is equal to negative 1 plus or minus square root of this is 1 plus 48. 16 times 3 is 48 upon 8. So I take quickly the calculator and get the values of this one. So it should be shift sine inverse of a fraction which is minus 1 plus, I write it out over here, minus 1 plus or minus square root of 49 upon 8. Square root of 49 is nothing but what? 7. Minus 1 plus 7 upon 8, and sine theta is equal to minus 1 minus 7 upon 8. So it becomes 6 upon 8. 6 upon 8 and sine theta is equal to negative 1. So theta is equal to sine inverse 6 upon 8, which can be written as 3 upon 4, and theta is equal to sine inverse negative 1. So I take two values. One is a positive value and one is a negative value. So sine negative 1 directly gives you the answer 270 degrees, whereas sine inverse 6 upon 8. So if I do by calculator, sine inverse 6 upon 8, it should be giving me something around 48.6 degrees. Now what is this? It is in for the theta range has been given as 0 to 360 degrees. So another angle will be 180 minus 48.6 degrees. So which is nothing but what? 131.4 degrees. So my final answer will be three different answers. First answer is 48.6 degrees, another one is 131.4 degrees, and the third one is 270 degrees. So these are the three angles for finding of this second question. Now we shall go to the third question. The variables x and y satisfy the equation x power n y is equal to c, where n and c are constant. X is equal to 1.1, y is equal to 5.2, and x is equal to 3.2, y is equal to 1.05. Find the values of n and c. So x power n y equal to c. So apply ln on both sides. X power n y equal to ln c. So it becomes x ln x and n ln x plus ln y is equal to ln c or ln c. Some people say as ln, some people say as ln, as you wish. N ln x plus ln y is equal to ln c. I have applied logarithms on both sides. Now we can substitute the values. So the first set of values is x is 1.1 and 5.2. So I get n ln 1.10 plus ln 5.20 is equal to ln c, and another value, let me do it out in different color, 3.2 and 1.50. So n ln 3.20 plus ln 1.05 is equal to ln c. So from here, if at all I want to subtract it out both, that should be the easiest way. I subtract both the equations and get the value of n. So I draw that, subtract both the equations. So ln c gets cancels and common. Ln 1.10 minus ln 3.20 plus ln 5.20 minus ln 1.05 equal to 0. From there I make n as a subject, which is minus of ln or ln 5.20 minus ln 1.05 divided by ln 1.10 minus ln 3.20. So we take quickly the calculator and substitute these values. So I'm simplifying this one in the calculator. So coming to the denominator, it is ln 1.10 minus ln 3.20. So when I simplify that, so I should be getting it out in three significant figures or 1.50. That's going to be the value of n. When you use in the calculator, you get the n value as 1.50. Now we have to substitute this n value in any one of the equation. I substitute in the first one. So when you are substituting the total full calculator display, so it is 1.49822777 to be on safer side. Ln 1.10 plus ln 5.20 should be equal to ln c. So c is equal to e to the power of this entire thing. Let me copy this one, e to the power of this. So I do e to the power of answer times ln. I took answer times because in the calculator when I use the answer I get the full calculated display. So answer times ln 1.10 plus ln 5.20. So I will be getting the full calculator display, which will be giving me 5.998 something around, so which is 6.00. So answer for C is 6.00. What else has been asked? Find the values of n and c. Then in the second part, explain why the graph is of ln y against ln x is a straight line. He's asking why the graph is going to be a straight line. So what is the equation we got it? We just copy this equation. Let me add a quage. I copied this equation and he says that y ln y against ln x is a straight line. So this can be written as ln y or ln y is equal to minus ln n ln x plus ln c or ln c. I am taking to this the other side. So you can see that when I compare this equation in the form of y is equal to mx plus c, mx plus c, compare it out. So the slope is going to be negative n and the constant is going to be ln c. So when I compare it out, it is in the standard form of y is equal to lx plus c. So as the equation is in the standard form, standard form, y equal to mx plus c, it is a straight line. It is a straight line. So as simple as that. So that is the reason only 1 mark has been given to that question. So that comes to question number 3. Coming to question number 4, using the expansion of cos 3x minus x and cos 3x plus x, prove that cos 2x minus cos 4x total divided by 2 is equal to 1 by 2 sin 3x sin x. So we should know cos a minus b formula. Cos a minus b formula is nothing but what? Cos a cos b plus sin a sin b, and cos a plus b formula is cos a cos b minus sin a sin b. So I use that one. So 1 upon 2 cos 2x minus cos 3x. So the question is 1 upon 2 cos 2x minus cos 4x. So it is 1 upon 2 cos 3x, 2x can be written as 3x minus x, whereas cos 4x can be written as 3x plus x. So cos a minus b formula. So I am using cos a cos b cos 3x cos x plus sin 3x sin x. Similarly, cos a plus b cos 3x cos x minus sin 3x sin x. Now expand it further, 1 upon 2, so you get it out, cos 3x cos x plus sin 3x sin x. Remove that bracket and multiply with minus, minus cos 3x cos x minus times minus x plus sin 3x sin x. Then cos 3x and cos x gets cancels. So 1 upon 2, it is 2 times sin 3x sin x. So 2 gets cancels. It's going to be sin 3x sin x. That's going to be the answer, which is asked us to prove in the first part. Now coming to the second part, what is asked in the second part of the question? Hence show that integral of sin 3x sin x is equal to 1 upon 8 root 3. So let us copy this question and start a new page. There it goes. That is the second part of the question, and he's asking us to prove this one. So just now we have proved that this entire thing is equal to 1 upon 2 cos 2x minus cos 4x. So dx, that has been proved in the first part. So 1 upon 2 is pulled outside. Cos 2x integral is nothing but what? Sin 2x upon 2 minus cos 4x integral is nothing but what? Sin 4x upon 4. And total limits is going to be pi upon 6 to pi upon. So I substitute the values and I got the answer. So you can check the calculations. The final answer is going to be root 3 upon 8. So that is the answer for question number 4. Now coming to question number 5, given that y equal to 0, x is equal to 1 in the differential equation, obtain an expression for y square in terms of x. So x divided by dx, the question is x divided by dx equal to y square plus 4. So y dy upon y square plus 4 is equal to 1 upon x dx. What is the procedure? Get y terms on one side and x terms on one side, including dy and dx. So I brought y square upon 4 to the left side and x I took to the other side. Then what should I be doing it out? Applying integral on both sides. Then multiply and divide by 2. Why should I multiply and divide by 2? Because there is a fact that if the derivative of the denominator derivative is present in the numerator, so once again, denominator, there is a function. Let me write any function denominator, its derivative should be present in numerator. Then the answer will be ln denominator f of x. So that is the easiest way to remember the formula. So there is a function in the denominator. If that function's derivative is present in the numerator, then the formula will be ln denominator. So therefore it is 1 upon 2 ln y square plus 4 is equal to 1 upon x integral is ln x plus we can write it as ln c. That will be easiest way to do that. And moreover, I write it as 1 upon 2 ln c. You can write it as plus c, you can write as ln c, you can write as 1 upon 2 ln c, as your wish. Constant can be, you can play around with the constant. Why I have written 1 upon 2 ln c? Because over here I have 1 upon 2 and everything is in the form of ln, so simplification will become easier. So now 1 upon 2 ln y square plus 4 is equal to, multiply over here with 2 and 2, so 1 upon 2, it becomes, take common, ln x square, that 2 goes to the power, ln x square plus ln c. So 1 upon 2, 1 upon 2 cancels, that is a reason. So ln y square plus 4 is equal to ln cx square, ln gets cancels, y square plus 4 is equal to cx square. Now has he given the values of y and x? Y is 0, x is 1. So 0 square plus 4 is equal to c times 1 square. So c is equal to, I get the value of c as 4. So that is the easiest way of getting the value of c. So c value is 4. So what will be the equation now? We have to get the equation also. This was the equation, or this was the equation. So y square plus 4 is equal to 4x square. So 4x square. What is he asking? Y square in terms of x. So make y square as a subject. Y square is equal to 4x square minus 4. Y square is equal to 4 common, x square minus 1. That's going to be the answer for question number 5. Coming to question number 6. The diagram shows a semicircle ACB with a center O and radius R. The angle BOC is x radians. The area of the shaded segment is quarter the area of the circle. Area of the shaded segment is quarter the area of the semicircle. Show that x satisfies this one. Area of the shaded region. This shaded region area should be equal to area of the sector minus triangle. Area of the sector minus triangle. So area of shaded region should be equal to area of sector minus area of triangle. So area of a sector formula is half r square theta minus area of a triangle formula will be half r square sine theta. So half r square theta minus half r square sine theta. So we know that this particular angle is x, so this has to be pi minus x. It has to be pi minus x because angle in a straight line is 180 degrees. So it becomes, and that is the area of the shaded region is equal to quarter the area of the semicircle. So first of all, we'll simplify this one. So half r square pi minus x minus half r square sine pi minus x. Sine pi minus x is going to be sine x. So we can remember that sine pi minus x is sine x. So it becomes 1 upon 2 r square pi minus x minus 1 upon 2 r square sine x. This is the area of the shaded region. Now what is given in the question? Shaded segment or shaded region is equal to quarter the area of the semicircle. This is equal to quarter the area of the semicircle. Area of a semicircle is pi r square by 2. Quarter the area of the semicircle. So I can take that r square by 2, I can take common. So it becomes pi minus x minus sine x is equal to r square by 2 over here also it becomes pi upon 4. So what am I going to get it out? So r square upon 2, r square upon 2 gets cancels. So pi minus x minus sine x is equal to pi upon 4. So I want to make x as a subject. I quickly add a paper page over here. So pi minus pi upon 4 minus sine x is equal to x. So x is equal to pi minus pi upon 4 is 3 pi by 4 minus sine x. I think so that is only been asked us to prove 3 pi by 4 minus sine x. So in the next part it is being asked that they show that the root lies between 1.3 and 1.5. So what I have done it out, I have just plugged in 1.3 and first of all I have to get it out f of x, get all the terms on one side and make an equation in terms of f of x, in terms of x. Then plug in 1.3, get a negative answer, plug in 1.5, get a positive answer. Then you can write that as f of 1.3 and f of 1.5 are having opposite signs, root lies between 1.3 and 1.5. That is the answer for the second part. Coming to the third part, use the iterative formula xn plus 1 is equal to 3 pi by 4 minus sin xn. Determine the root in 2 decimal places, giving each iteration in 4 decimal places. So I quickly add a page over there. So the iterative formula has been taken as xn plus 1 is equal to 3 pi by 4x, 3 pi by 4 minus sin xn. So what am I going to do? N is equal to 0. So x0 plus 1 is equal to, I write over here, x0 plus 1 is equal to x1 is equal to 3 pi by 4 minus sin x0. x0 value I take it as, let me move this one also to a bit aside. So x0 value I take it as, has he given x0 value? Nothing. So we can take x0 value anything. So just to the random, I'll be taking it as x0 value as maybe 2. Okay, so what am I going to do? You can take any value of x0, doesn't matter, it's going to come to the same. So use the mode of the calculator as degrees, radians. So it becomes 3 times pi upon 4 minus sine 2. x0 value can be taken as anything. So 4 decimal places is it. So 1.4469. That is the first iteration. Then what am I going to do with it? I am going to take the second iteration. So n is equal to 1. It becomes x1 plus 1 is equal to x2 is equal to 3 pi by 4 minus sine of x1. x1 value just now we got it as 1.4469. So go back and change it to 1.4469. So it becomes 1.3639. So that is the answer for the second iteration. Now I go for the third iteration. Then I quickly do it out. It's taking time. N is equal to 2. x2 plus 1 is equal to x3 is equal to 3 pi by 4 minus sine x2. x2 value has been 3639. So minus sine of 1.3639. So I go back and change it to 3639. So it becomes 1.3775. And then again I try n is equal to 3. So x3 plus 1 is equal to x4 is equal to 3 pi by 4 minus sine x3. x3 value just now we got it as 3779. So 3775, 1.3775. Simplify that. 775, 3775. So I get 1.3750. So I stop it here. Why do I stop it here? Because I see that when I want 2 decimal places, because the question asks for 2 decimal places. So this one 2 decimal places is 1.45 and this is 1.36 and 1.38 and 1.38. So you can see that it is repeating. So therefore the root is going to be 1.381. As soon as it repeats, that's going to be the answer. So 1.38 is going to be the final answer. Coming to question number 7, a complex number 2 plus 2y is denoted by u. Find the modulus of u. Modulus of u will be square root of 2 square plus 2 square, which is square root of 8, which is 2 root 2. Then argument theta is equal to, or argument of u is equal to tan inverse 2 upon 2, which is pi upon 4. Sketch on the argon diagram showing the points represented by the complex number 1, I and U. Shade the region in between them. So sketch an argon diagram showing the points representing the complex numbers 1, I and U. So quickly, what am I going to do? I'm going to draw a argon plane, x-axis and y-axis. X-axis is going to be my real axis and y-axis is going to be my imaginary axis, and this is the origin 1, 2, 3, then minus, then this is again on the y-axis 1, 2 and 3, minus 1, minus 2, 1. Where is 1? 1 is over here, 1 comma 0. Then I means 0 plus I, this is there. So I means 1, 0 plus 1 I. So it is should be 0 comma 1. 1 means 1 plus I times 0, so which is 1 comma 0. And finally U is 2 plus 2I, so which is 2 comma 2. So 2 comma 2, this is 1 point, 2 comma 2. So I got 3 points. What is asking? Shade the region whose points represent the complex numbers satisfying both the equations z minus I is less than or equal to z minus 1 is less than or equal to z minus I, and modulus of z minus u is less than or equal to 1. So we have to shade that region. So first one is z minus I is less than or equal to z minus 1 is less than or equal to z minus I. So let me write over here z minus 1 modulus is less than or equal to z minus I. So it's going to be a perpendicular bisector of a line joining 1 comma 0 and 0 comma 1 and shading towards this point 1 comma 0. 1 comma 0 and 0 comma 1. So the line joining 1 comma 0 and 0 comma 1, and it will be a perpendicular bisector. Let me draw a perpendicular bisector for that. Perpendicular bisector and shading towards 1 comma 0. Remember that it is shading towards 1 comma 0. That is the first one. Second one is nothing but what about the second one? Second one is modulus of z minus u is less than or equal to 1. Modulus of z minus u is less than or equal to 1 means it is a circle with center 2 comma 2 and radius 1, and it should be inside the circle. So I draw a circle with center 2 comma 2 and radius 1. Because it is 2 comma 2, so it should go to 3 and it should come to 1 and 3. Center is 2 comma 2 and inside the circle. So now it should be shaded towards 1 comma 0 and inside the circle. So this is going to be my answer. This is the shaded region which is inside the circle and also towards 1 comma 0. This is going to be the shaded part. That's it. Now coming to the last one, using your diagram, calculate the modulus of z for which the argument of z is the least. Argument of z is the least. So where is z? First of all, z is somewhere, anywhere on the, let me write it out, z is anywhere on this region. It can be, let me get it out into black color part. Z is over here inside this region and this red color part. Z is somewhere over here. Argument of z should be the least. He is asking that argument of z should be least. So when is that? So I am going to draw the argument means this angle. It is least over here. So it starts from here. It decreases, decreases, decreases. Follow the animation. The argument starts from here. It may be 45. Then it keeps on decreasing, 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 decreasing. Whenever it is a tangent, it is going to be the least. Then this is a position where it is least. So I want to find it out, this particular argument, or he's asking us to find it out the modulus, when the argument is least, at that time the modulus is going to be asked. So what is that particular distance is going to be asked. So I draw a triangle over here. So it is a tangent. Radius of this one is 1, and this point is 0, 0, and this point is 2, 2. So this length is going to be square root of 8. So it is a right angle triangle. Square root of 8 whole square is equal to 1 square plus, let this distance is x, x is square. So x is equal to 8 minus 1 square root of 7. So what is going to be the answer? Square root of 7 is going to be the answer. That's question number 7. Now question number 8. X plus 2 upon x plus 1 times x plus 3 in partial fractions. Using your answer, show that this is equal to. So 2 upon x plus 1 times x plus 3. I can write as a upon x plus 1 plus b upon x plus 3. So 2 equal to a times x plus 3 plus b times x plus 1. So plug in x is equal to minus 3. So 2 is equal to a times 0 plus b times minus 2. So minus 2b is equal to 2. So b equal to negative 1. Plug in x is equal to negative 1. So 2 is equal to a times 2 plus b times 0. So a is equal to 1. So what are the partial fractions? I got it out. 2 upon x plus 1 times x plus 3 is equal to 1 upon x plus 1 minus 1 upon x plus 3. Now what is being asked? Show that the whole square part of that one. So squaring on both sides for this. I do squaring. So here also I need to do squaring. So it becomes a square minus 2ab plus b square. A square minus 2ab plus b square. So just now we could able to get that this is 2 upon x plus 1 times x plus 3 is equal to this entire thing. So I plug that one. So 1 upon x plus 1 whole square as it is minus, this can be written as 1 upon x plus 1 minus 1 upon x plus 3 plus 1 upon x plus 3 whole square. So simplify that. It becomes 1 upon x plus 1 whole square minus 1 upon x plus 1 plus 1 upon x plus 3 plus 1 upon x plus 3 whole square. So that's going to be the answer. Now hence show that the integral of this one. So we have to find the integral of this. So I paste the image. We have to prove this one. So I'm going to write integral of 0 to 1 4 upon x plus 1 whole square and x plus 3 whole square dx will be equal to integral 0 to 1. This 4 upon x plus 1 whole square, x plus 3 whole square is nothing but what? Over here. So that is nothing but what? This one just now we have proved it out in the part 2. So I write that part 1 upon x plus 1 whole square minus 1 upon x plus 1 minus plus 1 upon x plus 3 plus 1 upon x plus 3 whole square dx. So 1 upon x plus 1 whole square integral is minus 1 upon x plus 1 minus ln x plus 1, then plus ln x plus 3 and minus 1 upon x plus 3 from the limits 0 to 1. So you can substitute the values and check the calculations. I have done it out to save the time. So answer is going to be 7 upon 12 minus ln 3 upon 2. Substitute the upper limit and lower limit and you can check the calculations over here. You should be getting the answer. That is a question number 8. Now finally question number 9. The diagram shows that y is equal to square root of 1 minus x by 1 plus x. By first differentiating 1 minus x by 1 plus x, obtain an expression for dy by dx in terms of x. So first y. y equal to 1 minus x upon 1 plus x. So dy by dx is equal to, quotient rule I follow, 1 plus x whole square. 1 plus x times derivative of 1 minus x is minus 1, minus 1 minus x, derivative of 1 plus x is 1. So it becomes minus 1 minus x minus 1 plus x divided by 1 plus x whole square. So x gets cancels, it is minus 2 upon 1 plus x whole square. That is the derivative of that one. Hence show that the gradient of the normal is this one. So I want to find, let this not be y, maybe y. So we cannot consider it as y because it has been already given as y. So I consider it as z dz by dx. Now in the question it has been given as y. So y is equal to square root of 1 minus x upon 1 plus x. So now I want dy by dx. Dy by dx is equal to 1 by 2 root of 1 minus x by 1 plus x, because remember square root of x derivative is 1 upon 2 root x. That is the easiest method to remember. Square root of x derivative is 1 upon 2 root x. So this is 1 upon 2 root of 1 minus x upon 1 plus x times derivative of this fraction. Derivative of this fraction just now we have do it as minus 2 upon 1 plus x whole square. So you can see that 2 gets cancels, negative. Root of 1 plus x goes to the numerator, root 1 minus x and 1 plus x whole square. Then square and square root, square and the square root will be able to cancel one time, and you will be getting it at root 1 minus x, and 1 plus x, 2 minus 1 upon 2 is 3 upon 2. What is that? This is 2 over here, this is 1 upon 2 over here. 2 minus 1 upon 2 is 3 upon 2. Now what we want the answer in this form, 1 plus x times root of 1 minus x square. So minus 1 upon root 1 minus x, this can be written as root 1 plus x times 1 plus x, because 1 of 3 upon 2 can be written as 1 plus 1 upon 2. So I write as whole power 1 and square root of 1 upon 1 plus x. Now what can I do? I can multiply these two. These two are in the form of a plus b into a minus b. So 1 plus x is as it is. Square root of a plus b into a minus b is a square minus b square. So once again I went quickly, maybe 2 in the power and 1 upon 2 in the power will cancel, becomes 3 upon 2. So I wrote that 3 upon 2. 3 upon 2 can be written as 1 plus 1 upon 2. This is 1, and that 1 upon 2 is the square root. Now that the terms under the square root becomes a plus b times a minus b, which is a square minus b square. This is slope of tangent. Derivative means slope of tangent. So slope of normal will be reciprocal and change the symbol. So it will be 1 minus x square under root times 1 plus x. This is going to be the slope of the normal. Finally, that's the reason, 5 marks question. Finally, what is being asked in the part, the gradient of the normal of the curve has its maximum value at point P shown in the diagram. Find by differentiation the x coordinate of P. So the gradient, this is the gradient, it is having the maximum value. So I have to find the derivative of this one. Let this be w. So dw by dx, product rule, 1 plus x. Just now we have learned chain rule also. We have learned that root derivative is 1 upon 2 root x derivative. So 1 plus x, derivative of this one is 1 upon 2 root 1 minus x square. Again minus x square derivative is minus 2x, chain rule. Then product rule, next time keep 1 minus x square under root as it is. 1 plus x derivative is 1. So what I have done it out, let me mark over here. This is one function p, this is one function q. So I have written p as it is, this is q prime. Next time I have written q as it is, and this is p prime. So product rule and chain rule has been used, and root x derivative has been wrote as 1 by 2 root x. Easy to simplify. Now it's a maximum point, so first derivative should be equal to 0. Equate this one to 0. 2 cancels. 1 plus x times minus x upon square root of 1 minus x square plus square root of 1 minus x square is equal to 0. So 0 is equal to minus x times 1 plus x plus square root 1 minus x square. square root whole square. Square and square root gets cancels. So 0 is equal to minus x square plus 1 minus x square. So I have simplified that one. So it becomes minus 2x square minus x plus 1 is equal to 0. So 2x square plus x minus 1 is equal to 0. So I have to get the value of x. So 2x minus 1 times x plus 1. Factors 2x minus 1 times x plus 1 is equal to 0. So when you check that, the factors is going to be 2x minus 1 times x plus 1 is equal to 0. So x is equal to 1 by 2 or x is equal to negative 1. But it is positive, x is positive because p is in the positive x-axis. Therefore, the final answer is x is equal to 1 upon 2. That's going to be the answer. That completes the paper. See you in the next paper. Bye.